Hey students, how you doing today? I hope you've had a great Wednesday graphing those dilations. Today is one of our two most important lessons of the year, in my opinion, and we're going to be graphing full-on transformations. Lots of dilations, reflections, translations, all in the same problems, graphing transformations. And yep, I have graph paper out, so this is for team graph paper. But I'm really hoping that at the end of this lesson, you will see how team graph paper is not the way to go with these problems. They're getting way too complicated. All right, so given this f of x graph, they want us to graph g of x equals negative f of x plus 3 over 5 minus 4. I typed up our transformations of functions kind of cheat sheet, and I've broken it into kind of two different halves. You've got horizontal transformations and vertical transformations. I'm going to talk horizontal first because those are involved with our x, and we usually talk about x first. Horizontal transformations are always inside the function. If you have a positive x, there's no reflection, but if you have a negative x, or this negative out front, that shows that there will be a y-axis reflection. If it's dividing by a, that's a horizontal dilation by a factor of a, and this x minus h shows a horizontal translation of h units. So if you're going to physically work the what's happening to the coordinates, you first multiply the coordinate by the dilation and the reflection, so you get this negative x, and then because it's going h units, and they already took care of the minus within the equation, you would add h to it. Because so for example, if this was x minus 2, it's going right 2, which means you need to add 2 to all the x coordinates. Yeah, kind of confusing. Verticals, those are always outside the function. A negative out front of the function would show a x-axis reflection. This b, it's also it's a multiplier times the function, so that demonstrates a vertical dilation by a factor of b. This plus k on the end, that shows that vertical translation, k units. And same thing, you first multiply the y-coordinate by the reflection and the dilation at the same time, and then you add the translation on the end. And I mentioned it last several days, but inside the function you do the opposite, outside the function you do exactly as it reads. As far as the y-coordinate goes, you're multiplying the function by the b, so you're multiplying the y-coordinates by the b. You're adding k to the function, so you're adding k to the y-coordinates. Whereas x stuff that's inside, you do the exact opposite. Because it says divided by a, opposite of dividing by a is multiplying by a. The opposite of subtracting an h value would be adding an h value. So if inside the equation, as far as what you do to the coordinates, opposite. And I'm going to be referring to this a lot over the next several days. So back to this problem. You first want to look at this equation here and figure out what transformations are occurring. Maybe break it up into insides and outsides. And I will. Because I have this divided by 5, that's just like this divided by a here. That's a horizontal dilation by a factor of a, or by 5. So I have a horizontal dilation by a factor of 5. But now that I think about it, you know what? If I'm on team graph paper, I wouldn't do that first. I would think about reflections before I'd think about dilations. So I'm actually going to cross this out. My apologies, everybody. I'm not used to being on team graph paper. I tend to do my reflections first if I was to do this problem on graph paper. So I'd actually first deal with this negative out front, and the negative out front, that is an x-axis reflection. So I first am going to do an x-axis reflection. Then I do the horizontal dilation by a factor of 5. So first I do my reflections, then I do dilations, then I would think about translations. So first my reflection, my dilation was this horizontal dilation by a factor of 5. And then start doing it through translations. This x plus 3 on the inside, that shows that we're going left 3. The minus 4 on the outside, that shows that we're going down 4. Okay, then go ahead and get your graph paper drawn and make sure that you leave yourself enough space. Some of these problems are going to require a lot of graph paper, and it can be kind of tough to know how much graph paper you need to show. I'm actually looking at my work from my team non-graph paper, so I actually know how high or low I'm supposed to go. So I'm going to start off like this. All right, go to a coordinate. I would pick one in order. I'm going to start with, no, that's the biggest one. I'm actually going to start with this 2, 5. So I go to 2, 5, 2, 1, 2, 3, 4, 5, and now I just run through these transformations. First, x-axis reflection. So x-axis reflection's this guy. So if I reflect it over this axis, it would go down to here. 1, 2, 3, 4, 5. So it's down here. Then I do a horizontal dilation by a factor of 5. Oh no, I'm looking at my previous problem. I think I've made a mistake with my other problem. With my team graph paper, I'm beginning to worry. Oh, no. I did right. Oh, team graph paper. This is confusing. First, I'm going to do the x-axis reflection. That'll put me down here. Then I need to do a horizontal dilation. That means I need to multiply my x-coordinate by 5. So if it's an x-coordinate of 2, if I multiply the x-coordinate by 5, it would become 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I go left 3, 1, 2, 3. Then I go down 4, 1, 2, 3, 4. That's confusing. Okay, second coordinate, 0, 3. First, I do an x-axis reflection. Oh wait, 0, 3. That's up 0, 3. I do an x-axis reflection. That would go down here. Then a horizontal dilation by a factor of 5. That means you're multiplying the x-coordinate by 5, but it's already at 0, so no multiplying needed. Then I go left 3 and down 4, and I end up here. Finally, my point -3, 7. So I first go to -3, 7. 2, 3, 4, 5, 6, 7. Okay, it starts off up here. I reflect over the x-axis, so it's going to go down to -7. So 1, 2, 3, 4, 5. Oh, it actually reflects down to here. Then a horizontal dilation by a factor of 3. This had an x-coordinate of -3. So if I multiply that x-coordinate by 5, it's going to be -15. So -3, 4, 5, 6. Wait, -3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then left 3, 1, 2, 3. Then down 4, 1, 2, 3, 4. So these would be my 3 coordinates, and then you connect the dots, and you'd end up with a problem like this. And we showed all our work, so it's done accurately. I just want to show you the team non-graph paper. When I did that, I ended up with coordinates at 7, -9, -3, -7, and -18, -11. And I'm pretty sure that matches up with those coordinates. I guess I could check this coordinate. It's way out here. If I got this coordinate right, I probably got the entire problem right. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, yep. And then -11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's in the right location. But wow, so much work, and it was hard for me to keep track of the accuracy of it. It's hard. Let me do a second example, and for team graph paper, we're going to use the exact same f of x graph, But this time for number 2, we are going to graph h of x equals 3 times f of negative parentheses x plus 6, close parentheses, plus 5. This is what I recommend doing. I recommend pausing this video, trying this problem out on your own, and then playing the video and seeing if you did it right. All right. So first, I deal with my reflections. I have this reflection. I have a negative on the inside. That demonstrates a y-axis reflection. Then I apply dilations. This is on the outside, so that's a vertical dilation. So vertical dilation by a factor of 3. The x plus 6 demonstrates that I'm going left 6. The plus 5 demonstrates that I'm going up 5. Okay, let's go ahead and get into this. Based off what I'm seeing from my previous, I'm going to need a lot of vertical space here, so I'm actually going to put my my axes right down here. So we have these original coordinates. I'm going to start off with the coordinate 2, 5. Zoom out a little bit. Okay, so I start off with the point 2, 1, 2, 3, 4, 5. From this point, first I do a y-axis reflection. This is my y-axis, so if y-axis reflection, it would move over here. Then a vertical dilation by a factor of 3. This currently has a y-coordinate of 5, so if it's a y-coordinate of 5, I need to multiply it by 3, so it's going to be 15. So it's currently at 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then I go left 6, 1, 2, 3, 4, 5, 6, up 5, 1, 2, 3, 4, 5. So I am way, way up here. Second coordinate, 0, 3. So I start at 0, 3. I do a y-axis reflection. It would stay right here. Vertical dilation by a factor of 3. That means that I'm multiplying the y-coordinate by 3. So it's currently at 3. It's going to move up to 9 then. So 3, 4, 5, 6, 7, 8, 9. Then I'm going to go left 6. 1, 2, 3, 4, 5, 6. And up 5. 1, 2, 3, 4, 5. So my second coordinate's there. Team graph paper, you're killing me. Third point, negative 3, 7. So I go to negative 3, 1, 2, 3, 4, 5, 6, 7. This is where it's going to get out of control. Negative 3, 7. First I do a y-axis reflection. So it reflects over to here. Then a vertical dilation by a factor of 3. So instead of a y-coordinate of 7, it's going to be a y-coordinate of 21. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Then left 6, 1, 2, 3, 4, 5, 6. Up 5, 1, 2, 3, 4, 5. And that would be my third point. I could connect the dots at that point. And that's the conclusion of this problem. It's really complicated. It's really hard, to do the counting. The reflection was fine. It's that dilation that's killing me. If I'm having to count from 7 all the way up to 21, you're just likely to make a silly mistake. So I really urge you, don't be team graph paper, be team non-graph paper. It's going to make your lives easier. And as a good lesson, this lesson actually took 2 minutes longer, and I was a little less accurate with my math. So I'm really not sure that's the best way to go. Anyway, you might hear students filing in the room right now. Hey, students. Anyway, they are here, and I need to move on with class. So I hope you enjoy this. Join Team Non-Graph Paper. See you tomorrow. Bye-bye.